All right, we're going to look at estimating derivatives. So basically using what we know about derivatives and what we know about other things in math to make estimates. So the derivative describes the instantaneous rate of change of a function. That's our definition. And as a reminder, that's going to be the change in the output, which is f of x, with respect to the input, which is x. And if you've seen that before, that was f of, say, x minus f of x naught over x minus x naught. So on a graph, if you look at this, we can think about it as the y minus an initial y value, x minus the initial x value. So we can estimate the derivative anywhere that we can estimate a rate of change, which in a graph, like I said, if you look at this, that should look familiar. That is the slope, and more specifically, the slope of the tangent line at a point. So if I look at a point and I can kind of see how the slope of the line at that point, that will be an estimate of my derivative. And for the AP test, just be aware that you should be prepared to be able to write equations of those tangent lines. If I'm looking at a table, well, then I just look at the closest difference quotient that I can make. Because the closest or the smallest difference quotient I can make, that's going to be my best estimate. So let's look at an example here in our graphs. So we want to estimate f prime of 1 for each of the graphs below. Whoops. Sorry, I'm getting other stuff pulled up. So estimating f prime of 1. So the slope at 1 for each of these graphs, well, for this first one, it's easy. We can actually calculate the slope. The slope is going to be a rise of 1, 2, 3, 4, 5 over a run of 1, 2, 3, 4. So the slope is 5 over 4, which is, well, we can just leave it like that. So f prime of 1 in this first graph is 5/4, and that's just from looking at the graph and finding the slope at x equals 1. The second one is a little bit trickier because we don't have a nice clean graph like that. So instead, we kind of just imagine the tangent line, kind of sketch that out, and then we can sort of look and make an estimate based off of that. So I'm going to say, kind of eyeballing it here, at 2, I'm at about 2 on the plot here. And at 0, I'm at about -2 here. So that means I'm going from 0 to 2 in the y-axis. So change in 2 over a run in 1. So our derivative is about 2. Again, that's an estimate, but that's what we're looking at in this unit, is estimates. Oops, I already wrote that, so I can ignore that. All right, let's look at tables. Estimate f prime of -14 for the functions depicted. So these are tables. They're telling me a bunch of values for them. So if I look at f prime of -14, where does that fall on my table? That's going to be in between -15 and -13. Those are the closest two values I can use. So I'm just going to do the difference quotient there. So it doesn't matter which order I do them in as long as I'm consistent. So I can put these two first, or I can put these two first, as long as I'm consistent. So -69 minus -13 divided by -63 minus -15. And if I switch these, then the top and bottom, the negatives would be switched. So I get the same results, basically. And Running through that, I'm going to get negative 69, negative 6 on the top. What did I do there? That is completely wrong, sorry. Strike that. Sorry, it should be negative 69 minus negative 63. I can change the order. Like I said, I can put these first or these first. So negative 69 minus negative 63 over negative 13 minus negative 15. Or I could flop that and do negative 63 minus negative 69 over negative 15 minus negative 13. Either way, I'm going to get negative 6 over positive 2 for a rate of change of negative 3. Now, if I look down here, we notice that negative 14 is on my table. So what I want to do is look at what values do I have and which of these are closest. So I have the smallest delta x. So that's going to be the negative 13. So again, I'm just going to pick the output value, 95 minus 89 over negative 13 minus negative 14. And that will give me a rate of change of 6 over 1 for an average rate of change, or an an estimate of the rate of change of 6. So those are two ways we can do estimates. Let me know what questions you have.